Imagine landing in an airport where almost everything beneath the runway was once ocean. That is becoming reality in Dalian, China, where engineers have created about 20 square kilometers of artificial land in Jinzhou Bay. The project includes 2 huge runways and a 500,000 square meter terminal. But the strangest part is underground. Before giant aircraft can use this airport, engineers must make the soft seabed stable enough to carry them. And that challenge is far harder than simply filling the ocean with dirt. The runway was not the first thing China had to build. China had to build the land underneath it. Off the coast of Dalian, in Liaodong Province, a huge new airport is taking shape in Jinzhou Bay. But unlike most airports, this one did not begin with a flat piece of land waiting for bulldozers. The project began with the sea. The Dalian Jinzhouwan International Airport is being built on an artificial island covering about 20 square kilometers. That is roughly the size of a small city district, and from above, the site looks less like a normal construction zone and more like a giant platform placed directly on the water. Current Chinese government reporting describes it as the country's first offshore artificial island airport. And this is not a tiny regional airstrip. The first phase is planned around 2 long parallel runways. One is designed to be 3,600 meters long, while the other will stretch 3,400 meters. Beside them will stand a 500,000 square meter T1 terminal, large enough for a planned annual capacity of about 43 million passengers, along with major cargo and aircraft handling facilities. Put simply, China is not building a runway in the sea. It is building an entire airport city on land that had to be created first. That explains why the project looks so unusual from the air. The empty space surrounding the construction is not unfinished land waiting for development. It is water. The solid platform underneath the future airport is the product of one of the project's biggest engineering operations, land reclamation. And there's a reason Dalian needs such an enormous new airport. Its existing Dalian Jinzhouwan International Airport sits inside the developed urban area, leaving limited room for major expansion. Chinese project officials have said the old airport had reached the point where moving the airport became necessary, while long-term planning identified the Jinzhou Bay location as the suitable large airport site. That is what makes the decision so interesting. The ocean was not chosen because building there was easy. It was chosen because there was simply far more usable space. And China had already done something similar in other parts of Asia. Airports, such as Kansai in Japan and Hong Kong International, were also built on reclaimed land. So the basic idea was not completely new. The scale in Dalian, however, is extraordinary. Older reporting from 2014 put the airport project at about 26.3 billion yuan, roughly $4.3 billion at the exchange rate used at the time. That is where the familiar for billion-dollar airport figure comes from. But that number should be treated as a historical estimate, not the current confirmed cost of the project. By 2026, the project had moved far beyond the early concept. Government reporting said the main reclamation work had been completed, creating roughly 20.1 square kilometers of artificial land. The airport's basic shape could now be seen from above, and that creates the first major mystery. If engineers can simply fill an area of shallow sea with enough material, why not build the airport immediately? Because filling the sea does not automatically create solid ground. The material may be there. The island may look finished, but deep underneath it, the original seabed is still there. And that is where the real engineering battle begins. Dalian did not choose the ocean because it was easier. It chose the ocean because the city was running out of room. Dalian is a major coastal city in northeastern China, surrounded by mountains, developed urban areas, and the sea. Its existing airport, Dalian Jinzhouwan International Airport, has served the city for decades. But as air traffic in the city's economy grew, expanding the airport became increasingly difficult. An airport needs something that a normal building does not: enormous amounts of open, uninterrupted space. A terminal can be expanded upward. A road can sometimes be widened. But runways are different. They need long, straight stretches of land, with carefully controlled distances between them. Aircraft also need large taxiways, parking areas, cargo facilities, safety zones, and space for future expansion. Trying to create all of that inside a crowded city is extremely difficult. So engineers looked toward Jinzhou Bay. The location offered something Dalian could not easily create on land: a huge open area where an airport could be designed almost from scratch. The plan was ambitious. The first phase of Dalian Jinzhouwan International Airport includes 2 runways and a 500,000 square meter terminal, with a planned capacity of about 43 million passengers every year. The larger master plan goes even further, with 4 runways and long-term capacity of around 80 million passengers annually. That means this is not simply a replacement runway for the old airport. It is designed as a major aviation hub. And the location has another advantage. Dalian sits in a strategic position along Northeast Asia's transportation routes. The city connects China with important markets in Japan, South Korea, Russia, and other parts of the region. A larger airport can support passenger travel, cargo movement, tourism, and business connections. But there's a catch. The same water that provides all this space also creates the project's biggest engineering problem. Imagine taking a giant sheet of land and placing it over soft ground that has been underwater for thousands of years. At first glance, it may look solid. Heavy machinery can drive across the surface. Roads can be constructed. Buildings can begin to rise. But deep below, the soil can still contain large amounts of water. When millions of tons of material and massive airport structures are placed on top, that pressure can force the soft layers underneath to compress. The ground slowly moves. This process is called settlement. For an ordinary piece of land, some settlement may be manageable. For an airport runway, it could become a serious problem. A runway must remain smooth and stable because aircraft are moving across at a high speed while carrying enormous loads. Even small differences in ground movement can matter. So the challenge facing Dalian was never simply, can China fill the ocean? China has reclaimed land before. The harder question was, can China make that reclaimed land behave like reliable airport ground? That question changed the entire construction strategy. Instead of treating the artificial island as finished the moment it emerged from the water, engineers had to spend years preparing the ground beneath the future airport. The island had to be filled. The soil had to be strengthened. Water had to be pushed out of weak layers. Settlement had to be controlled and monitored. Only then could the airport itself safely rise on top. And this is where the project becomes much more interesting. Because once you understand why Dalian needed the island, the next question is almost impossible to ignore. How do you actually create about 20 square kilometers of solid land where the sea used to be? The answer involves an amount of material so large that ordinary measurements stop making sense. More than 280 million cubic meters of material went into creating the ground beneath this airport. That number is difficult to picture. So forget about trucks for a moment. Forget about individual piles of soil. Imagine an area of ocean being gradually transformed into a massive platform large enough to hold runways, taxiways, terminals, aircraft stands, roads, and everything else an international airport needs. That is what happened in Jinzhou Bay. The artificial island created for Dalian Jinzhouwan International Airport covers roughly 20 square kilometers. It stretches about 6.2 kilometers from end to end and around 3.5 kilometers across at its widest points. The closest part of the island sits roughly 3 kilometers from the existing coastline. From above, the transformation is almost difficult to recognize. Where there was once open water, there is now a huge engineered surface. But creating that surface was not as simple as dumping dirt into the sea until the water disappeared. The first challenge was controlling where the material went. An artificial island has to be formed according to a precise shape. Its outer boundaries must be protected, while the interior has to be raised to the required levels for future airport infrastructure. Engineers, therefore, had to manage enormous quantities of fill while working in a marine environment where waves, tides, weather, and water movement could constantly interfere with construction. And the quantities involved were extraordinary. By the end of 2025, official reports said the main reclamation work had been completed, with more than 280 million cubic meters of material used to create the roughly 20 square kilometer platform. To understand what that means, imagine filling millions of large swimming pools. Except this material was not being placed into one giant container. It was being used to manufacture an entire piece of land. And there was another reason the process had to be carefully controlled. Every additional layer placed on top of the seabed added weight. That weight was useful because the project ultimately needed the ground to become stronger. But it also created pressure on the weak soil underneath. The original seabed was not designed to support an airport. It had formed naturally beneath the water, with layers of marine sediment accumulated over long periods of time. Once engineers placed huge quantities of fill on top, the pressure began changing those underground layers. The soil could compress. Water trapped inside, it could be forced through the surrounding material, and the surface could gradually settle. That is why an artificial island cannot simply be judged by what it looks like from above. From a surface, it may appear completely finished. Underground, the ground can still be changing. For an airport, that is a critical distinction. A warehouse or parking lot might tolerate some movement. A runway carrying heavily loaded aircraft requires much tighter control. If one section settles faster than another, the surface can develop unwanted differences in elevation. So while the island was being created, another operation was taking place beneath the future airport. Engineers were preparing the ground itself. The reclamation operation created the space. Ground treatment would determine whether that space could actually support an airport. And this is where the project moves from an enormous construction story into something much more complicated. Because the biggest danger was no longer visible. It was buried underneath hundreds of millions of cubic meters of reclaimed material. The island had been created. Now, China had to make sure it would stay stable. And that meant fighting a problem that could continue long after the ocean disappeared from view. The biggest threat to this airport is not the waves above it. It is movement beneath the runway. From the surface, the artificial island can look solid and permanent. Heavy construction equipment can move across it. Roads can be laid out. Massive structures can begin rising. But deep below the surface, the original seabed is still made of soft marine soil. And that creates a problem. When engineers placed hundreds of millions of cubic meters of material on top of that seabed, the enormous weight began pressing down on the layers underneath. The soil could compress, while water trapped inside those layers needed somewhere to escape. If that process happened naturally and unevenly, the airport could eventually experience different levels of settlement in different areas. For a normal piece of reclaimed land, that would already be a concern. For an airport, it is much more serious. A runway has to remain extremely smooth and predictable. Aircraft can weigh hundreds of tons, and their landing gear concentrates that weight onto relatively small areas. Every landing also creates powerful forces as the aircraft touches the surface and begins braking. That means engineers cannot simply wait and hope the ground settles by itself. They have to control the process. At Jinzhouwan, ground treatment work became one of the project's largest hidden operations. Official reports describe complex geological conditions, thick layers of soft soil, and the need for extensive foundation treatment across the artificial island. By 2025, authorities reported that ground treatment had covered roughly 10 square kilometers and involved around 340,000 ground treatment piles of different types. But the numbers become even more surprising when you look at the drainage system. Around 12 million drainage boards were installed as part of the ground treatment work. Together, the drainage boards were reported to have a total length of roughly 200,000 kilometers. That is almost 5 times the circumference of Earth. These drainage systems have a simple purpose. They give water trapped inside the soft soil a faster path toward the surface. Think of a seabed like a wet sponge. When you press down on a sponge, water tries to escape. But deep layers of soil do not release water quickly. If engineers place a huge weight on top, the trapped water can take a long time to move through the soil. Drainage systems help accelerate that process. As water escapes, the soil becomes more compact, the ground becomes stronger, and engineers can monitor how much settlement is occurring before the airport begins operating. This is one of the strangest parts of the entire project, because much of the most important work cannot be seen once construction is complete. Passengers will eventually walk through a modern terminal. Aircraft will taxi across enormous runways. Cars and trains will move toward the airport. But underneath all of it will be millions of engineered components designed to make the ground behave in a predictable way. The project also uses piles and other foundation treatment techniques to improve the strength and stability of the reclaimed ground. The goal is not to pretend that the seabed was naturally solid. The goal is to transform its behavior. Engineers need the ground to settle in a controlled way before the airport reaches full operation, rather than allowing major changes to continue unexpectedly underneath critical infrastructure. And that is why creating the island was only the beginning. The visible part of the project, the runways, terminal control systems, aircraft stands, can only work if the invisible part underneath them performs first. The ocean has been pushed back. The island has been created. Now the ground has to prove that it can carry an airport. And once engineers could begin turning that artificial platform into stable construction ground, the project finally started to look like what it was supposed to become: an airport. Once the ground could finally support construction, the project began to change before everyone's eyes. For years, the most important work had been happening beneath the surface. Now, the structures that would eventually be visible to passengers could begin taking shape. The first phase of Dalian Jinzhouwan International Airport is planned around 2 enormous runways. One will stretch about 3,600 meters, while the other will be about 3,400 meters long. Between and around them will be the taxiways, aircraft parking areas, navigation systems, service roads, and other infrastructure required to turn a giant artificial island into a functioning airport. But the runways are only part of the picture. At the center of the airport will be a massive terminal building covering roughly 500,000 square meters. That is not simply a large building with departure gates. It is the heart of an entire transportation system designed to handle tens of millions of passengers every year. The planned first phase capacity is around 43 million passengers annually, along with approximately 550,000 tons of cargo and 330,000 aircraft movements. Those numbers reveal something important. China is not treating this as an isolated airport for Dalian. It is designing the facility as a major regional aviation hub. And that becomes even clearer when you look at the airport's long-term master plan. The larger development is planned to eventually include 4 runways and a much larger terminal system, with a projected capacity of around 80 million passengers per year. In other words, the first 2 runways are only the beginning. But building the airport itself creates another problem. The island may be several kilometers offshore, but passengers cannot simply drive across the water. An airport needs a connection to the city. That means China has had to build another layer of infrastructure around the artificial island. A major cross-sea road connection is being developed to link the airport with the mainland. The planned route is about 2.85 kilometers long, with 8 lanes and a design speed of 80 kilometers per hour. And roads are only part of the transportation plan. Rail and metro connections are also being prepared to bring passengers from Dalian directly toward the new airport. This matters because the airport's location could otherwise become its greatest weakness. An airport in the middle of the bay might have enormous space, but that space is useless if passengers cannot reach it quickly and reliably. So the project is becoming something much larger than an airport construction site. It is becoming an entire transportation ecosystem. First, engineers created the land. Then they strengthened the ground. Now they are building runways, terminals, roads, bridges, and rail connections on top of it. And each layer depends on the one beneath it. If the artificial island had not been created, there would be no airport. If the ground had not been stabilized, there would be no safe runways. And without the cross-sea transportation network, even a completed airport would struggle to function as the regional hub planners envision. This is what makes the project so unusual. The airport is not being added to an existing city. The infrastructure is being built in the opposite order. First came the ocean, then came the land, then came the foundation. And only after that could the airport itself begin rising. But there is one question that becomes harder to ignore with every new layer of construction. How much does it actually cost to create an entire piece of land, stabilize it, build an airport on top, and then connect that airport back to the mainland? Because the famous $4 billion price tag tells only part of the story. The ocean gave Dalian something the city could not easily create on land: space. But that space came with a price. And the famous $4 billion figure attached to this airport needs some explanation. When the project was reported in its earlier stages, the estimated investment was around 26.3 billion yuan, which was roughly $4.3 billion at the exchange rate used at the time. That is where the familiar for billion dollars airport figure came from. But the project did not remain frozen at that original estimate. As the design, construction requirements, supporting infrastructure, and development plans evolved, later official figures became much higher. Current Chinese government reporting puts the first phase investment at around 50.9 billion yuan. So the $4 billion number is useful for understanding the project's original scale, but it should not be presented as the airport's current confirmed total cost. And that difference matters because this is not simply the construction of a terminal and 2 runways. The project includes the artificial island itself, enormous amounts of reclamation material, deep ground treatment, drainage systems, foundations, runways, taxiways, terminals, roads, bridges, utilities, and connections to the mainland. Every one of those systems adds another layer of engineering. And the ocean creates challenges that an ordinary land-based airport would not face. The artificial island has to deal with settlement. The surrounding coastline has to be protected. Water has to be managed. Drainage systems have to function. Structures have to withstand marine conditions. And the entire transportation network connecting the airport to Dalian has to operate reliably. There is also a much bigger question hanging over the project. Will the artificial land continue performing as expected decades after the airport opens? That is why ground monitoring is so important. Engineers are not simply trying to make the island stable today. They need to understand how it behaves over time. Settlement does not necessarily stop the moment construction ends. The goal is to control and predict it so that critical airport infrastructure remains within acceptable limits. This is one reason the most impressive numbers from the project are not always the ones passengers will ever see. The terminal may eventually become one of the most recognizable structures on the island. The runways may stretch for kilometers, but beneath them will be the drainage systems, piles, compacted soil, foundations, monitoring, equipment, and layers of engineered ground that make the visible airport possible. There's also an environmental dimension. Because this is a massive coastal construction project, Engineers have had to account for water management, flood control, ecological protection, and the impact of creating such a large artificial landmass in the bay. The project has also been presented as incorporating energy-saving and low-carbon technologies as the airport develops. So the question is no longer simply whether China can build an airport offshore. Clearly, it can create the physical platform and construct the infrastructure. The bigger question is whether the enormous investment will produce enough long-term value to justify the complexity. Dalian's answer is based on scale. A larger airport could provide the city with room for decades of aviation growth. It could support more international routes, more cargo, more tourism, and stronger connections across Northeast Asia. And if the long-term plans are realized, the airport could eventually handle around 80 million passengers every year. That is an enormous bet on the future. But it also explains why China was willing to take on an engineering problem that most cities would never even consider. Dalian did not simply need another airport. It wanted enough space to build an aviation hub for the next generation. And now that the island exists, the foundations are being treated, and the airport itself is rising. The final question becomes the most important one. What does China expect this enormous artificial island to change once aircraft finally begin landing there? China did not build this island simply to give Dalian a new place for airplanes to land. The bigger goal is to turn the artificial island into one of the most important transportation hubs in northeastern China. The first phase of Dalian Jinzhouwan International Airport is planned to handle around 43 million passengers every year, along with roughly 550,000 tons of cargo and about 330,000 aircraft movements. Those numbers alone would make it a major airport. But the long-term plan is considerably larger. The complete master plan calls for 4 runways and a much larger terminal system, with the potential to handle around 80 million passengers annually and approximately 1.5 million tons of cargo. That changes the way you should look at the island. It is not simply an airport. It is a piece of new territory designed around aviation. And its location matters. Dalian sits on the southern tip of Liaodong Peninsula, facing some of the busiest economic centers in Northeast Asia. Japan and South Korea are relatively close, while the city also has strong connections with other parts of China and the wider region. A larger airport gives Dalian more room to expand those connections. More passengers can mean more international routes. More cargo capacity can support manufacturers, logistics companies, and businesses that depend on fast transportation. And a larger aviation hub can also strengthen tourism and business travel. But none of that is guaranteed. The airport is still being built. The island may now exist, but the completed airport has not yet spent decades proving itself under real-world conditions. That distinction is important. It is easy to look at the enormous artificial island and assume the hardest part is already over. In some ways, it is. China has created roughly 20 square kilometers of new land where there used to be water. More than 280 million cubic meters of material went into the reclamation process. Ground treatment systems have been installed across huge sections of the island, and the terminal, runways, transportation links, and supporting infrastructure are now taking shape. But the true test will come later. Aircraft will land. Passengers will arrive. Cargo will move through the terminals. Roads and rail connections will carry people back toward Dalian. And underneath all of it, the artificial ground will continue to perform the job engineers designed it to do. That is the part most passengers will never think about. When someone walks through the terminal, they will see glass, steel, gates, shops, signs, and aircraft outside the windows. They probably will not think about the seabed beneath their feet. They will not see the drainage systems buried underground. They will not see the piles supporting treated ground. They will not see the hundreds of millions of cubic meters of material that transform the bay. But all of it will be there. And that is what makes the project so remarkable. China did not simply build an airport beside the ocean. It first had to manufacture the land that the airport needed. The sea became the construction site. The seabed became the engineering problem. And the artificial island became the foundation for an entire aviation hub. If the project performs as planned, Dalian will gain something that was almost impossible to create within the existing city: enormous room for aviation growth. The long-term vision reaches far beyond the first 2 runways. For runways, tens of millions of passengers, massive cargo capacity, road and rail connections, and an airport designed to connect Dalian more directly with the rest of Northeast Asia. But perhaps the most fascinating part is what the project tells us about modern infrastructure. When a city runs out of land, engineers can sometimes create more. Not by moving a mountain, not by building another skyscraper, but by turning part of the ocean into a carefully engineered piece of territory. And that brings the story back to the image we started with. An aircraft will eventually touch down on a runway in Jinzhou Bay. To the passengers inside, it may feel completely ordinary, but beneath those wheels will be something extraordinary. They will not be landing on natural ground. They will be landing on an island that did not exist before this project began. An island created from the sea, strengthened from below, connected to the mainland, and built to carry an entire airport. That is the real achievement behind China's enormous offshore airport. The runway is impressive. The terminal is impressive. The scale is impressive. But the most important thing was built before any of them: the ground itself.